Hello everyone, welcome to you all for this physics class. In the last class we have discussed about the rules to draw ray diagram, okay, and we have seen four rules. We have seen four rules. We were discussing about the light chapter, right? And the four rules, where the first rule that we have gone through was about, if at all, if the incident ray, is parallel to principal axis, then the reflected ray must pass through the focus, principal focus. This was the first rule. Second rule that we have seen, okay, the second rule is, if the incident ray passes through principal focus, then the reflected ray must be parallel to the principal axis. This is the second rule, which is exactly opposite to the first rule. Right here, the incident ray, if the incident ray is parallel to the principal axis, then the reflected ray must pass through the principal focus. Okay, so this is one side. Second rule is, if the incident ray passes through the principal focus, then the reflected ray must be parallel to the principal axis. Okay, so this was the second rule. Third rule was, third rule that we have seen is, if the incident ray passes through the center of curvature, that is C, okay, C, then the reflected ray must pass along the same path. Okay. So if the incident ray is passing through the center of curvature, that means whenever the light ray passes through the center of curvature, and if it falls onto the mirror, that point will be making 90-degree angle with the surface of the mirror. So whenever this light ray, when it is incident at 90 to the surface of the mirror, okay, so there the reflection takes place in the same path. It will be reflected back in the same path, making the angle of incidence and angle of reflection 0. Okay, so whenever the light ray is incident perpendicular to the surface of the mirror, okay, so then what happens? The angle of incidence and the angle of reflection will be 0. Is that clear? So whenever that happens, when the light ray passes through the center of curvature. Okay, so at that time the angle formed, okay, that is with the surface of the mirror and the incident ray will be, if it is 90 degree, then the angle of incidence and angle of reflection will be 0. The same when it passes through the principal axis also. When a light ray is passing through the principal axis or along the principal axis, there also it forms 90 degree with the mirror. So at that time also it is going to reflect back in the same path. Okay. Fourth one, that is FD if the incident ray hits at the pole or falls at the pole, okay, then the reflected ray obeys the second law of reflection, which means that here when the incident ray, okay, hits at pole, the principal axis will act as a normal, okay, and the reflected ray, the light ray will be reflected in such a way that the angle of reflection will be equal to the angle of incidence. Okay, so that is what the fourth point is. This is we have seen in the previous video. In order to have more clarification on these 4 rules, okay, you can just go through the video, the previous video, okay, so there you will understand, okay, on reflection, the rules for drawing a ray diagram. You can see that video, then you can see the diagram. Okay, so this is just a revision that I have taken, the 4 rules, so that like now we will be looking into the image formation with the help of a concave mirror. Is that clear? Okay, hope this is understood and hope you have like copied and you have understood this one. So next we will move on to the next topic. Okay, that is image formation. Image formation in case of concave mirror. Okay, when the object is placed at different position, okay, we have discussed, right? So during the convex, while checking with the concave and convex mirror, when discussing about the convex and concave mirror, so it was told that the convex mirror and the plane mirror always produces or forms or okay, virtual images are obtained. It gives only virtual images. So whereas the concave mirror is the one mirror which will give you both real and virtual images. Is that clear? So now, how is that possible that when it is going to give us the real image and when it is going to give the virtual images? Okay. So at what position of the object, at what position if we give the object, it is going to give the real image, and what position if we place the object, we get the virtual image. That we will be seeing here. We have almost 6 different diagrams, 6 different positions of the object that we will be dealing with one by one. Okay. So one thing you have to remember here, that is plane mirror and the convex mirror will always give you virtual images. Okay, this one point you have to remember. And the second point you have to remember is in the convex mirror. So as we have said, the real images are which are caught on the screen, right? So here in the concave and convex, in the spherical mirrors, so you can just redefine it, the image, the real image and the virtual image. If the images are formed in front of the mirror, okay, that is reflecting surface. In front of the mirror means it is understood reflecting surface. Okay, so if the images are formed after reflection, if the images are formed in front of the mirror, we call it as real image, and if the images are formed behind the mirror after reflection, okay, then we call it as virtual image. Okay. So now, image formation. In concave mirror. Image formation in concave mirror. First one. So first we'll see the position of the object when the object is placed at infinity. When the object is placed at infinity. When the object is placed at infinity. Infinity means very far. Okay? Very far away from the mirror. For example, you can say sun. Sun is very far away from the mirror. Okay? It is very far away from us, right? Sun. So in order to capture the image of the sun, okay? In order to capture the image of the sun, so how can we define it? By drawing the ray diagram. Okay? So let us see now. Suppose here we get two cases. One case when the rays are parallel. Okay? When the rays are parallel, and the other one when the rays are oblique to the principal axis. Okay? So first we will see when the incident rays are parallel. Okay? Suppose if I take the concave mirror, if I draw the concave mirror. So this is the, which I am shading is the non-reflecting surface, and concave mirror which is curved inwards. Okay? The reflecting surface is curved inwards, that is called as concave mirror, and this we name it as aperture M dash. Okay? And here this would be the center of the mirror, and let us call it as pole, center of the reflecting surface. Center of the reflecting surface is the, or center of the aperture is the pole. Okay? We call it as pole. Now let me choose one center. Okay? If at all I take this as circle, let me take this point as center of curvature, and half of this would be principal focus. Okay? So let this be the center of curvature and this be the principal focus F. Okay? And the line joining the center of curvature and the pole is the principal axis. And now I am going to draw the dotted line that shows that the object is at infinity. Okay? So this is Y. Let me call it as X. Okay? So now, if I take the object, if I draw an object here, if I am going to draw an object, okay? So this is the object here. Okay? Object is drawn here. So now, from here, okay, from infinity, from an infinity, now the rays are coming parallel to the incident rays are parallel to the principal axis. Incident rays are parallel to the principal axis. I'll draw this image here, one more. Okay. From here also, I'll be drawing a parallel line, an incident ray which is parallel to the principal axis. So arrow mark towards the concave mirror indicates that it is an incident ray. Okay, these two are the incident parallel beam of light. Okay, so after reflection, as and when this incident ray hits the surface, reflecting surface of the concave mirror, it is reflected back in such a way. We know that the first rule, if you remember, if the incident ray is parallel to the principal axis, okay, then the reflected ray must pass through the principal focus. Now this is the reflected ray. Incident ray must pass through the principal focus. So one more reflected ray will draw. Okay, so this one, or you can take here also. So if you one more if there is a light is focused from here, okay, so even if it is passing along if the incident ray is passing along the principal axis, then it is reflected back along the same path. Why? Because this is going to make, if I draw one tangent to this, if I draw one tangent, you could see that this incident ray is perpendicular to the surface of the mirror, right? So similarly here, one more parallel ray we have, parallel incident ray parallel to the principal axis. This incident ray is parallel to the principal axis. Again, after reflection, this must pass through the principal focus according to the first rule of ray diagram. Okay, so now you could see where the reflected rays are meeting, that is where the image formed. That is where the image is formed. Here you could see that the image is formed, the image which is formed here, okay, the image which is formed here is at F, principal focus, and on the principal axis, right? It is on the principal axis at F. So here the image formed is point size. So whenever the rays are parallel to the principal axis, okay, all the rays are reflected and they are meeting at one point, that is principal focus, and the image formed is point size here. The image formed is point size. So now, so this is the ray diagram, okay, this is the ray diagram. You could see here, so we have drawn the image and all the rays are parallel and the object is placed at infinity. Then after the ray diagram, what is that we have to see? So once you have to read where the object is placed, okay, based on that you have to draw the ray diagram, okay. Only two rays you have to follow, any two rays, okay. Here we have followed one rule we have followed, that is parallel to the principal axis, and the reflected ray will be passing through the principal focus, okay. This is one rule that we have followed, okay. And another one is that if the ray is passing along if the incident ray is passing along the principal axis, it is reflected along the same path. So these two rules we have followed here. So there we have discussed 4. So this is the 5th one where they have not mentioned, but you can consider it because this is also almost same like the 4th rule, where if the incident ray is passing through the center of curvature, it will be moving along in the same path. The reflected ray will move along the same path or pass along the same path. Similarly, here also, whenever the light incident ray is passing through the principal axis, it is going to reflect back along the same path. Okay, so this you should remember. Is it clear now? Okay, so hope. Now, what all we have to see? Once we have done with the diagram, the first point that you have to note is nature of the image. Nature of the image. So what is nature of the image? Okay, nature of the image is nothing but you have to tell whether it is real image or virtual image, and you all know the real images are always inverted, so you have to write in combination real and inverted. If it is a virtual image, you have to write in a combination that is virtual and erect. Is that clear? So nature of the image means you have to tell whether it is real and inverted or virtual and erect. Okay, so now how to find out this? The nature of the image here is, so where is the image formed? So image is formed in front of the mirror at F, right? So image is formed in front of the mirror. So this is a real image. So the nature of the image is real and inverted. So real images are always inverted. So real and inverted. Real and inverted. Is that clear? Now, second point what you have to see is position of the object. Position of the image, sorry. Position of the image. Now, position of the image means where the reflected rays are intersecting, where the reflected rays are meeting. Okay, so that point you have to consider for the position of. That is the point where image is formed. So where the reflected rays are meeting. So this is one reflected ray and this is another reflected ray, right? So this is one reflected ray, this is another reflected ray. You could see. So these two are meeting at F. Okay, so the position of the image is at focus, principal focus F. Okay, F is principal focus F. If you want, you can write it as principal focus. Okay, at F. And the third one, okay, third is size of the image. Size of the image. Size of the image, that is whether it is magnified or it is enlarged or it is diminished or it is highly diminished. Highly diminished whenever you get the image of point size, okay, so where you can't measure. If you are getting a point size are very small, wherein you can't measure it, you can say highly diminished. If you can measure, you can say diminished. Okay, if it is larger than the object, okay, if it is larger than the object, you can say magnified. If it is of same size, then you have to write it as same size. If the image obtained is smaller than the object, you can say diminished. Or it is very smaller, much smaller, then you can say it as highly diminished. So here the object, compared to object, the image is very small. So this is highly diminished. So here I write size of the image is highly diminished. Highly diminished. Is that clear? So the image is highly diminished. Okay, so this is what we have understood here in the first one. When the object is placed at infinity, in the first case, when the incident rays are parallel to the principal axis. Okay, so we got this. The image we are getting at focus, that is P. Okay, that is F. Sorry, we are getting the image at principal focus F. The nature of the image is real and inverted because we are getting on the same side here, in front of the reflecting surface or in front of the mirror. Okay. Okay, and size of the image is highly diminished. Is that clear? Next. Okay, you have understood now. Now, second one. Okay. Remember that these 3 points, the nature of the image, position of the image, and size of the image is what you should write after drawing the ray diagram. Okay. At the end, you will see in a table that could be clear. Okay. This is the first one. Now the second. Now the first position we have seen. I said that there are 6 positions, right? When the object is placed at infinity, when the rays are parallel. So one more. We get one more. Okay. That is when object is at infinity. I said one is parallel to the principal axis. When the rays are parallel. When the object is at infinity and the incident rays are parallel. Okay, this is the first one which we have seen. Now again, if the object is at infinity and the rays are oblique. Okay, and if the rays are oblique, they are not parallel to the principal axis. So now you see. Suppose if this is the concave mirror. This is the concave mirror. And center of this is P, center of the reflecting surface is P, and the aperture will name it as mm dash. Okay, and if I have to draw the principal axis, okay, if I take center of curvature here C, and here if I name it as principal focus. So you have to be very clear while drawing this one. Okay, this is the F point. Okay, and this. So now, if suppose if this is the sun, okay, here we have a sun, okay, and from the sun we are getting the rays. Sun rays are made to incident on the concave mirror, okay, and the sun rays which are falling on the mirror are parallel to each other. Okay, so let me take only 2 rays as of now. Okay, and where they are going to focus. Let me take one paper here. Okay, if I am going to take a paper. So as and when they are going to, they are And now if I take a piece of paper, and if I try to capture this, okay, so where we are going to get the focus point, okay. Now let me draw the reflected ray. This you will be doing the experiment in the class, okay. In the lab, when you take the concave mirror, and if you take the image, okay, which is far away from the, very far away from, or through the window if you see, okay, in the lab, and if you just focus onto that, okay, as and when the light rays fall, and slightly you have to keep, if the mirror is like this, you have to keep the object here, okay, so then you could see that the image will be falling onto this, okay. So you could see here all the rays are reflected, and you could see one point here, okay, on this paper. So this is the principal focus F, okay. This would be the principal focus F. So take a concave mirror. If you have to find out the focal length, okay, of the object, which is of the convex lens, okay, concave mirror. If you want to find the focal length of a concave mirror, okay, in the lab, what we do, we take the concave mirror and we focus onto the object which is very far distant, okay, and we'll take the screen, okay, and screen and the mirror, okay. If this is a screen, okay, then mirror will be placed just slightly in, not in the same parallel, slightly oblique, okay. So then you could see the image will be made to fall onto the screen, okay. So you get this focus, you will get, and by this focus and this P and F, you can find the center of the screen and center of the mirror, okay, center of the mirror holder you can take. So because you will be keeping mirror in the mirror holder, okay, and center of that to the, suppose this is the mirror, center of this to the F you can measure, that will be the focal length. Hope you have understood. So here all the rays which are coming from the sun are reflected once they fall into the concave mirror, and they all are converged here, and this convergent point is called as principal focus. And when you measure the distance from principal focus to the pole, that will be your focal length, okay. So this is the second one. This helps you in the lab, okay, whenever you want to when they ask you to find the focal length of a concave mirror, okay, you can use this method. Now second one, second position is beyond, when the object is placed beyond center of curvature. Center of curvature, that is beyond C. When the object is placed, okay, when the object is placed beyond center of curvature. Now again, this is the concave mirror. This is the concave mirror. Let me draw one parallel axis. Let me take this as P, and let me point C here and F here, okay. Now object is placed at a definite distance behind the, or beyond the C, okay. So here I am going to again take two rules, okay. I am going to follow two rules. One is, if the incident ray is parallel to the principal axis, okay, then the reflected ray must pass through the principal focus. The reflected ray must pass through the principal focus. This is one. Second one, when the incident ray passes through the principal focus, when the incident ray passes through the principal focus, okay, then the reflected ray must be parallel to the principal axis. This is the reflected ray. Okay. First rule, when the incident ray is parallel to the principal axis, the reflected ray is passing through the principal focus. And the second rule that I have taken here is, when the incident ray is passing through the principal focus, the reflected ray is parallel to the principal axis. And you could see this ray and this reflected ray. This is the one reflected ray and this is the second reflected ray. The first reflected ray and the second reflected ray are meeting at this point, right? At this point, now I am going to draw a vertical line. Okay. Now, where these two reflected rays are meeting, there you have to mark the arrow mark. Okay. So, where these two reflected rays are meeting, there you have to draw the arrow mark. Okay. Which shows, now you see, here the arrow mark of the object is upside. Okay. And the arrow mark of the image formed is downwards. That means inverted. Okay. So, now we will see the 3 points. Nature of the image. So, what is the nature of the image? So, again here the image is formed in front of the mirror and you could see here it is inverted. So, it is real and inverted. Second one is position of the object. Image. Position of the image. So, position of the image. How is the position of the image? Where is the position of the image? It is between C and F. Between C and F. That is between center of curvature and principal focus. And third one is size of the image. Size of the image. So here size of the image you could see it is diminished. Okay. Diminished also you can write, or you can write it as smaller than the object. It is diminished. The size of the image is diminished, or you can write smaller than the object. Is that clear? Second point. So when the object is beyond the center of curvature, okay, when the object is placed beyond center of curvature, okay, when the object is placed beyond center of curvature, so you get the nature of the image is real and inverted. The position of the image is between C and F, and size of the image is smaller in size as that of the object. Is that clear? And what are the two rules that we have adopted here? One rule is, when the incident ray is passing parallel to the principal axis, the reflected ray must pass through the principal focus, right? That is the first rule. And one more rule, that is second rule we have taken here. When the incident ray passes through the principal focus, then the reflected ray will be parallel to the principal axis. Clear? So, this is the second. Okay, this one is the second rule. Now, third position. We'll move on to the third position. Okay. We'll move on to the third position. That is when the object is placed at C. When the object is placed at C. Here, if you take the correct dimensions and if you draw the correct angle of reflection and incidence, then you will be getting the correct image. Okay. So third one, when the object is placed at C, center of curvature. Okay. So again, I am going to draw concave mirror whose reflecting surface is bent inwards or whose reflecting surface is curved inwards. So every time I am repeating the definition for the concave mirror so that it would be easy for you to understand. As and when you see this video, you will be thorough to define the concave mirror. Okay, and this is M dash is the aperture. Okay, now this is P, center of the reflecting surface. Let me take C, center of curvature, and here it has F, principal focus F. Okay. So now the object is placed at C. When the object is placed at C, okay, when the object is placed at C, when the object is placed at C, okay, which rules you have to follow? One, the same rule, the first rule will follow, that is when the incident ray is parallel, to the principal axis, the reflected ray must pass through the principal focus. I'll take the same rule, rather to avoid confusion. Okay. Second one I'm going to take, that is when the incident ray passes through the principal focus. When the incident ray passes through the principal focus. Okay. When the incident ray passes through the principal focus, this is the second rule, then the reflected ray must pass through the reflected ray must be parallel to the principal axis. Now, okay, so incident ray is passing through the principal focus, okay, and here you could see that the reflected ray is parallel to the principal axis. Okay, so one reflected ray is this one, and the second, these two reflected rays are meeting at this point. So here I am going to draw the image, and here they are meeting, so there I will draw the arrow mark. There I am going to draw the arrow mark. Okay, so this is the arrow mark, this is the image, black. Okay, so this is the image. So here you could see again nature. It is in front of nature of the image. It is in front of the image, so it is real and inverted. Then position of the object. You can see it is at C. Okay, and if you see size of the image, so position of the image, okay, is at C. The position of the image is at C, and size of the image will be same as that of the object. Is that clear? Okay. So here, see here, the object is placed at C, okay, and we have taken two rules, that is, one is if the incident ray passes parallel to the principal axis, then the reflected ray must pass through the principal focus, and if the incident ray is passing through the principal focus, then the reflected ray must be parallel to the principal axis. And where these two reflected rays will meet, there we are going to draw the image, and we found that the image is real and inverted. The position of the image, we found that the image is found at C, and the size, we could see that both are of equal size. So object size and the image size both are same. Okay, so whenever you place the object at C, then you will be getting the image at C itself, and the size of the image will be same. Okay, and it will be, the nature of the image will be real and inverted. Okay. Now moving on to the fourth ray diagram. Okay. When the object is placed now at C, now it is between, when the object is placed between C and F. One thing you have to remember, so whenever you are bringing the object closer to the mirror, the size of the image increases, and if you are taking the object away from the mirror, then the size of the image will decrease. Okay, so hope it is clear. Yes, so what did I say? That is, whenever the object, when the object is brought closer to the, closer to the mirror, okay, when the object is brought closer to the mirror, the size of the image will increase. If it is taken away from the mirror, then the size of the image will diminish or decrease. Okay, now we will see this one, the fourth one. Let me draw a concave mirror whose reflecting surface is curved inwards. Okay. Now, if I draw principal axis is the line passing through the center of curvature and pole. So this is the principal axis. Okay. So let me consider here C to be with. Okay. Let me consider C here. Okay. And F here. Now the object is placed between C and F. You can take proper scale and you can draw. So now the object is placed between C and F. Okay. Again, here the first rule that I will be following is if the incident ray is parallel to the principal axis, if the incident ray is parallel to the principal axis, then the reflected ray must pass through the principal focus. The reflected ray must pass through the principal focus. This is one point. Okay. Second point, what I'll do, I'll take that the ray is passing through the, okay, you can take passing through the center of curvature here. For that, I have to just increase this aperture. Okay. So here, if I take the ray passing through the center of curvature. Okay. So when the incident ray is passing through the center of curvature, then it is reflected back along the same path. It is reflected back along the same path. Okay. So now these two reflected rays are meeting at this point. So here I am going to draw the image. And this is my image. Right? This is the image. So here again you could see here, when the object is placed between C and F, the image is formed beyond C. Right? So when the object was placed beyond C, the image was in between C and F. That was in the second one. When the object was placed beyond C, the image we got was between C and F. And here, when the object is placed between C and F, the image is formed beyond F. Again, it is in front of the mirror, so it is real and inverted. And size you could see, as and when it is going, the object is moving near or closer to the concave mirror, you could see that the image is magnified. It is increasing, size of the image is increasing. So here again, if you have to discuss the nature of the image, so nature of the image is what? Real and inverted. Real and inverted. And position beyond C. Position of the object beyond C. And the size of the image is enlarged. Size of the image is enlarged. Okay. So this is about the third position. Okay. So we'll move on to the next position now. That is fifth one, where the image is placed at F. The image is placed at F. The image is placed at F. Okay. I'll just briefly explain that. Okay. So what you can do is, you can try these two. You can try these two on your own, the fifth and sixth, when the object is placed at F and between P and F. Between P and F. Okay. These two you can try at home. Okay. What do you have to do? Again, draw the concave mirror and draw the principal axis. Take point C, take point F, and then P. When you place the object here at F, okay, roughly I am showing, you can try it home, at F. So one, you can take that here, one ray will be falling at the pole, okay, and it should be reflected back, obeying the second law of reflection. Okay, so this is, and one more you can take passing through the center of curvature. Okay, so here when it is passing through the center of curvature, you find that these two are parallel. The reflected rays are parallel, they won't be meeting, but we assume that they are going to meet on the same side, that is in front of the mirror at infinity. So when the object was at infinity, the image was formed at f. So here when the object is placed at f, it is assumed that the image will be formed at f, at infinity. Okay, so this is what about when the object is placed at f. If it is between p and f, you will get the virtual image. So hope this we will be seeing in the next class. We will be seeing the last one, that is the sixth one. This was the fifth one, the sixth position where the object is placed between p and f, where we will be getting the virtual image. So this is the only one position of the object where you get the virtual image. Is it not interesting? Because you know, in the convex mirror as well as in the plane mirror, we get only virtual images, but this is the concave mirror where you get both real and virtual images, and this is the only one position. When you place the object between p and f, you will be getting the virtual image. Okay, so thank you so much. Please watch this video and go through these slides so that you understand where all the position of the object and how the image is formed. Okay, thank you so much.